Okay, so in this video I'm going to have a look at the factor theorem, and we're going to have a look at this particular equation here. We're going to have a look at solving this equation using the factor theorem. Now, the factor theorem very generally says that if the root of an equation is, let's say, a, then x minus a is going to be a factor. So what we're going to do first in order to solve this is guess, if you like, a root and check it out. So what we're going to do is just take, let's say, x is equal to 1 first of all. So we're going to put 1 in here and see what happens. So in other words, we're going to put 1 in here, raised to the power of 5, minus 17, 1 to the power of 4, minus 19, 1 to the power of 3, plus 27, 1 to the power of 2, plus 13 times 1 minus 10. So we want to see, does this equal 0? Now when you do out the left hand side here, you do find that you do get 0. So in other words, x is equal to 1 is a root, or a 0, or it's where one part of this graph is going to cut the x-axis. So that means by the factor theorem then that x minus 1 is a factor of this expression here. So what we can do is divide x minus 1 into this here, and that'll give us another factor, if you like. So let's do that. So we're going to take x minus 1 and we're going to divide it into 6x to the power of 5 minus 17x to the power of 4 minus 19x cubed plus 27x squared plus 13x minus 10. Okay, so let's start then. We divide the x into the 6x to the power of 5, that'll give us 6x to the power of 4. Multiply then, so you get 6x to the power of 5 minus 6x to the power of 4. So what we're going to do next then is just put a bracket around here and subtract. So this will cancel, and this will give us minus 11x to the power of 4. I'm going to bring down the minus 19x and start all over again. X into minus 11x to the power of 4 is minus 11x to the power of 3. Multiply, so you get minus 11x to the power of 4, minus minus is plus 11x cubed. This should be a 19x cubed here, by the way. So let's just subtract this, and this is minus 19x cubed here. So this will disappear, this here becomes a minus, so we end up with minus 30x cubed. Okay, so now we're going to bring down the plus 27x squared and start again. So divide x into minus 30x cubed, that'll give us minus 30x squared. So multiply, we get minus 30x cubed, minus minus is plus 30x squared. Put a line under here and again subtract. So again this will disappear, give us 0. This here becomes a minus, so we end up with minus 3x squared. Bring down the plus 13x and start again. So x into minus 3x squared is minus 3x. Multiply, you get minus 3x squared, minus minus is plus 3x. Put a line under here again and subtract again. It's just the same thing over and over again. This becomes minus, so we get plus 10x. Bring down the minus 10. Divide x into 10x, so you get plus 10. Multiply, 10 times x is plus 10x, plus times minus minus, 10 times 1, 10. Put a line underneath, and you can see here that if we subtract these two here, we will get 0 remainder, which means this was the factor that we determined initially, so this thing here is another factor. Okay, so let's just look at what we have so far. We have our x minus 1, which we determined was a factor initially, and now we've just found another factor, and that factor is 6x to the power of 4 minus 11x cubed minus 30x squared, let's see, minus 3x plus 10. And that, when we multiply those two together, will give us our original expression, which was 6x to the power of 5 minus 17x to the power of 4, and so on, all the way out to minus 10. Okay, so we have this one, and now we have this factor here. So what we need to do is take this factor here and determine a root for this factor here. So we're going to try again. We're going to try x is equal to 1. So if we put 1 in for each x here, we'll get 6 times 1 to the power of 4 minus 11 times 1 cubed minus 30 times 1 to the power of 2 minus 3 times 1 plus 10. So when you do that, you actually get minus 28. You don't, in other words, get 0. So x equal to 1 is not a root of this factor here. So let's try x is equal to minus 1. So when you put in minus 1, 6 times minus 1 to the power of 4 minus 11 times minus 1 cubed minus 30 times minus 1 squared minus 3 times minus 1 plus 10. In this case you do get 0. So in other words, x is equal to minus 1 is a root. So by the factor theorem then, x plus 1 is a factor. So again, what we can do here is take the x plus 1, divide it into this here to give us another factor. So let's do that. It's just more long division. So we're going to take our x plus 1, we're going to divide that in to 6x to the power of 4 minus 11x cubed minus 30x squared minus 3x plus 10. Okay, so let's do this then. X into 6x to the power of 4 is 6x cubed. Multiply, you get 6x to the power of 4 plus 6x cubed. Again, let's just subtract this. So you get, this becomes minus, so you get minus 17x cubed. Bring down the minus 30x squared. Start again. So x into minus 17x cubed is minus 17x squared. Multiply, you get minus 17x cubed, plus minus is minus 17x squared. Put a line underneath and subtract again. So this time this will disappear, this becomes plus. So we end up with minus 13x squared. Bring down the minus 3x, start again. Okay, so x into minus 13x squared is minus 13x. Multiply, you get minus 13x squared, plus minus is minus 13x. Put a line underneath again, subtract again. So this becomes a plus here. So that's minus 3 plus 13, that will give us plus 10x. Bring down the plus 10. And start again. So x into 10x is plus 10. Multiply, you get 10x plus 10. And you can see here that if we subtract those two, we will get 0. So again, this is a factor. So what we've got to do now is let's just look at all the factors that we have so far. We started with x minus 1, then we worked out that x plus 1 was a factor, and now we've ended up with 6x cubed minus 17x squared minus 13x plus 10. This is our new factor, and again if we multiply all those three together, we'll end up with our original function, if you like, our original expression, 6x to the power of 5 minus 17x to the power of 4, and so on all the way out to minus 10. So now what we've got to do is break this one down. We have two factors here, two linear factors if you like. This is a cubic here. We can break that down further. So same thing again. We're going to try x is equal to 1. So if you put 1 in here, here, and here, you will not get 0. I'm not going to do it, but you do not get 0. Okay, so this one doesn't work. If you try x is equal to minus 1, so if you put minus 1 in here, here, and here, you do get 0. So in other words, 6, and if we put in minus 1 cubed, minus 17 minus 1 squared, minus 13 times minus 1 plus 10, you do get 0. So again, that means that x is equal to minus 1 is a root. So that just means that x plus 1 is a factor. Okay, so now we have another factor, and it happens to be the same factor that we got earlier on. So we have repeated roots there, in other words. So what we've got to do now, finally, I hope this is the last time anyway, x plus 1, we've got to divide into that cubic expression that we had earlier, which was 6x cubed minus 17x squared minus 13x plus 10. So if we divide this in, let's see, what do we get? X into 6x cubed is 6x squared. Multiply, you get 6x cubed plus 6x squared. Put a bracket around here again and subtract. That will turn into minus, so you get minus 23x squared. Bring down the minus 13x. Here we get minus 23x. Let's see, multiply, you get minus 23x squared, minus plus is minus 23x. So let's just subtract these ones. And this becomes a plus, so you get minus 13 plus 23, which is plus 10x. Bring down the plus 10. Divide the x into 10x, you get plus 10. Multiply, you get 10x plus 10. Put a line underneath again, subtract, and you can see again here that this will just give us 0. So this here is also a factor. So now let's see what we have. So we started again with x minus 1 as a factor. We discovered that x plus 1 is a factor also, and then we discovered that another x plus 1 is a factor. And now we have just worked out that 6x squared minus 23x plus 10 is also a factor. And again, if you multiply all those four things out, you will get 6x to the power of 5, this original function, minus 17x power of 4, and so on, all the way out to minus 10. Okay, so we have three of our kind of linear factors here, if you like, and we have this quadratic factor here. So let's see if we can break this down into more factors. We have 6x squared minus 23 x plus 10, and we want that to be equal to 0. Now I know that if I try just factorizing it, it's not going to work. So really I'm going to have to use the minus b formula here. So I can see that a is equal to 6, b is equal to minus 23, and c is equal to 10. So my x then is going to be equal to minus b, which is minus 23, which is plus 23, plus or minus the square root of b squared, which is minus 23 squared, minus 4 times a, which is 6, times c, which is 10, and that's all over twice 6. So let's work out our two x values. So it's going to be 23 plus or minus the square root of something over 12. So when you work out the discriminant here, this bit underneath here, you should get 289. So that'll give us our two values. In other words, you've got x is equal to 23 plus the square root of 289 over 12, or 23 minus the square root of 289 over 12. And when you work those two out, you get, on this side you get 10 over 3, or you get a half here. This will give us a half. Okay, so now we have all our roots. I'll just work out or write down the roots first. So our roots are x is equal to 1, x is equal to minus 1, x is equal to minus 1, x is equal to 10 over 3, and x is equal to a half. So that would mean then that our factors are x minus 1, x plus 1, x plus 1, x minus 10 over 3, and x minus a half. If you multiply all of those out, all these 5 brackets out, you will get your original expression 6x to the power of 5 minus 17x to the power of 4, and so on out as far as minus 10. So we've broken this quintic expression here down into its 5 factors using the factor theorem. And that's it for this video.